Other problems we deal with in trigonometry are angles involving elevation and depression. Now, what are angles of elevation and depression? There's a nice diagram on the screen now. We look at an angle of elevation as the angle that an observer makes when he stands over here and he looks up from the horizontal. It's this particular angle we are interested in. That is called the angle of elevation. Now let's have a look at the angle of depression. That is measured from the horizontal as well. If you stand, for instance, on top of this lighthouse here and you look at that ship, then the angle that is formed from the horizontal to your line of sight, that is called the angle of depression. With angle of elevation and depression, a lot of errors are made, especially with the angle of depression. I've got two problems for you, one involving a tree and the other one involving a cliff. Let's have a look at problem one. Here we've got a tree and you stand 20 meters from that tree and you look up and you see that angle of 35 degrees. You see the top of the tree at 35 degrees. Let t be the height, then I know for this angle that the opposite is the height of the tree t, the adjacent is 20, tangent 35 equals t on 20, cross multiply the 20 by the tangent of 35, so the t then becomes 20 times the tangent of 35 and that equals 14 meters. Now in problem 2 we are standing on a 35-meter cliff and we observe an angle of depression when we look at the ship of 15 degrees. How far is the ship from shore? Now here's the mistake, because a lot of people, they regard that angle there to be 15 degrees, but that's not the case. This one is 15 degrees, but you can make use of properties of parallel lines to conclude that that angle there is 15 degrees. And then we know that the tangent again of 15 degrees must be 35 divided by d. Consequently, d must be equal to 35 divided by the tangent of 15, and that should come to 130.62 meters.